Today's lesson is a combination of 4.4 and 4.5 together. We're going to start off by just recalling what we've learned from last lesson. So when solving equations, we're going to follow the steps 1 through 4. Okay, so let's try with this example. 2 over 3 times k minus 4 is equal to 4 plus 2k. So we want to clear any fractions. That's step number 1. Okay, so I do this by identifying the lowest common denominator. So the lowest common denominator is 3. Well, how do I know this? Well, this fraction actually has a denominator, which is 3. Okay, so that's this term, and that's the only term on the left. This is one whole term on the left side of the equal sign. Okay, now on the right, I have 2 terms. Both of them have an invisible denominator of 1. Okay, so the lowest common multiple between 3, 1, and 1 is 3. So that's how I know that my lowest common denominator is 3. Okay, so I'm going to multiply all 3 terms in my equation by 3 in order for me to eliminate my fraction. Okay, now my denominator is canceled out with the numerator 3. So I no longer have fractions, which is what I wanted. Okay, so now I'm going to write the numerator of my fraction 2 times what's in the bracket. And then I can simplify my left side here. So 3 times 4 is 12. And 3 times 2k is 6k. Okay, and now step 2 says expand and remove all brackets. So on my left side, I'm going to expand and remove the brackets. And my right side, I'm just going to rewrite it as is. And then I'm going to continue writing over here because I ran out of room. And then step 3 says to rearrange your like terms together. So I'm going to put all of my k terms on the left side of the equal sign and all my constants on the right. And then making sure that I change the operation to its opposite when my terms are moving from one side of the equal sign to the other. Okay, and then simplifying like terms. Okay, and then step 4 says to isolate the variable. So I'm going to divide both sides by -4 so that k is alone. And I find that value of k is -5. Okay. So let's move on to 4.4, which demonstrates how information is modeled with formulas and how to rearrange the formula according to what we are using the formula to solve for. Describe an algebraic relationship between 2 or more variables is how we defined a formula. Okay, so for example, like the formula for area of a rectangle is length times width. So it describes the relationship between length and width to get area. Formulas can be rearranged to isolate for different variables. To rearrange a formula in terms of a variable, we have to isolate the term that contains the variable and then isolate the variable. So sometimes, for example, when you're dealing with area is equal to length times width, okay, sometimes we may already have the area value. So, and we may, let's say we know what the length value is as well. What we're trying to do is find what the width is. But this formula is ranged to isolate for A. So we have to rearrange this formula sometimes in order to isolate for our unknown. So if we didn't know what, let's say, width was, then we have to move our length over to the other side, which then would be A divided by L is equal to W. Okay, so rearranging formulas, this is exactly what it is. Okay. Now remember, just while I'm here, LW means length times width. But remember, we're trying to stay away from using that X to represent multiplication because we may confuse it with the variable X. Okay, so writing LW, I understand that means length times width. Another thing to note is that you're going to see me using the cursive L to represent length, because if I use just the non-cursive letter form of L, you can get that very confused with my number 1. So I usually use cursive L to just differentiate between L and 1. In geometry, an exterior angle of a triangle is equal to the sum of 2 opposite interior angles. So D is equal to A plus B. Now it's asking us to rearrange the formula to express A in terms of B and D. To express A means to isolate A. So rearrange the formula so that A is on its own. Right now the formula has D isolated. I want to rearrange it so that A is isolated in terms of B and D. So in terms of B and D, that means isolate A so that it's equal to B and D. Okay, so I'm going to start off by rewriting the formula that was provided to me in the question. And now I'm going to isolate A. So in order for me to do that, I need to bring B over to the other side. So it becomes D minus B is equal to A. Okay, so now I'm done rearranging my formula to express A. B, the circumference of a circle in terms of its radius is given by the formula C is equal to 2 pi r. Okay, so hopefully you know that this means pi. In elementary school, you use 3.14 to represent pi. In high school, we no longer use 3.14. We just use the pi button on our calculator. Okay, more on pi in later units in this course. So the circumference is equal to 2 pi r, and r means radius. So rearrange the formula to isolate for r. So I'm going to start off by rewriting my formula. Okay, and now I want to isolate for r. So I'm going to divide both sides by 2 pi. And when I do that, these two pi's will cancel each other out. So on my right side, I'm just left with r. And then on my left side, I'm left with c is equal to 2 pi. We don't have any values for c and 2, so we can't actually find the value or solve for r, but we have rearranged the formula. Next, C. The area, represented by capital A, of a square is related to the length of one of its sides, S, by the formula A is equal to S squared. So we know that area, going back to area of rectangle, is length times width. The more correct formula to use for area of a square is A is equal to side squared. Okay, this is the formula for a rectangle. Area of a rectangle. This is the correct formula for area of a square. Okay, in a rectangle, our length and width are different lengths, so they have different values. But in a square, each side is exactly the same length. Okay, so instead of using length and width to represent different values, you can just use S, stands for side. Okay, so S times S is equal to S squared, right? Remember, when bases are the same and you're multiplying, you just add the exponents. Okay, let's go back to the question. So find the length of the side of the square with the area of 32 squared centimeters. So it gives us the value for A. So A is 32. So now we're trying to find the value of S. So first what I'm going to do is I'm going to isolate for S. Okay, S is not isolated. This exponent 2 is in the way. So I'm going to bring 2 to the other side like I do with any other question when I'm trying to isolate for a variable. Now, when you're bringing an exponent over to the other side, it becomes its opposite operation, just like any other term when we're bringing another term to the other side. But now, the opposite operation of an exponent, 2, is a square root. Okay, so the exponent 2, okay, is squaring something. So the opposite of squaring is square rooting, which is like that. Okay, so when I'm bringing over my square to the other side, it becomes its opposite operation. And you're going to square root the term that's on the other side of the equal sign, which is A. And now it's asking us to solve for S, given that A is 32. So now I'm going to substitute, now that I've isolated for S, I'm going to substitute my value that I'm given for A. And this is not a perfect square, so we're going to have to use our calculator unless you have impeccable mental math skills. And so in the calculator, you're going to determine the square root of 32, which is 5.7. The question asks us to round our answer to the nearest tenth. Nearest tenth means 1 decimal place. Okay, so 5.7 is equal to S. And that dot on top of the equal sign means approximately. Now, because my question was presented to me in words, I'm going to answer in words with the therefore statement. The side length of the square is approximately 5.7 centimeters. So that's the end of 4.4. So 4.4 is just rearranging formulas, okay? So there's some homework questions for you to try there. Let's move on to 4.5. 4.5 is just a small extension of 4.4, still rearranging, but just in word problems now. When we're presenting a question in words, we must convert those words into an algebraic expression or algebraic equation. Okay, sometimes it's difficult for us to understand what the question is asking us when it's in words. So here's a chart with keywords that you should look for in the question to help create your expression or your equation. So when you see the word increased, that means addition. Decreased means subtraction. Sum means addition. Difference means subtraction. Doubled means you're going to multiply a value by 2. Tripled means multiply by 3. Twice means multiply by 2. More means addition. Less means subtraction. The same means equal to. Is in math means equal to. Okay, and something else to remember, whenever you are converting words into an algebraic sentence, make sure that you start off with a let statement. Okay, so we touched upon that last lesson, but we're going to practice writing let statements today. Okay, so example 1, write an algebraic expression to represent each description. So I'm going to let x represent the number in each of the following examples. A, double a number. So remember we're letting x represent our number. So double it would be 2x. Okay, and we understand that 2x means 2 times x. B, a third of a number. So remember your number is x. So 1/3 of it would be dividing it by 3, or 1/3x. We can write it either way. Okay, because remember our last lesson we were talking about how this really means 1/3 times x, which when you simplify is x/3, which is what this says over here. Five more than a number. So remember, more means addition. 5 more, add 5 from then whatever the number is, which is x. So x plus 5. 3 less than, triple a number. So 3 less than, which means we're going to subtract 3 from the number that is tripled. Example 2, write an algebraic expression to represent each sentence. Then solve. 5 times a number is 160. I'm going to start off with my let statement. Let x represent the number. So 5 times a number is, remember is means equals to, so equals to 160. So 5 times a number is equal to 160. Now it's asking us to solve. So I'm going to solve for x. B, an area increased by 17 is 61. So let A represent the area. You can use any variable you want. This is just what I'm using, but you can pick another one if you want. So is 61, okay, an area increased by 17. Okay, so now I'm going to solve. Four more than double a number is 22. Let x represent the number. So is 22. 4 more than double a number. And then solve. If you can understand what the question is asking, you could probably solve it. A lot of students, their biggest obstacle is understanding what the words on the page is asking them to do. So this is how we understand what the question is asking us, is by identifying those keywords in the problem and writing down the expression or the equation little by little according to what we're presented in the question with. D, the sum of 2 consecutive integers is 53. Now, 2 consecutive integers, that means one number after the other. So consecutive means one in this case, integer, so whole number, after the other. So 1 and then 2 are consecutive. 35, 36 are consecutive. One integer after the other. Okay, so in order. Okay, so the sum, let's start with our let statement. So let x represent the smaller number. So there's two, integers specifically in this question. So I'm only writing a let statement for one of the numbers. I'm not writing another variable for the other number because we can't solve if we have two unknown variables. Okay, if you have x plus y is equal to 53, you can't solve for x or y unless you know one of the other values. You can only solve for x if you know what y is and you know what this value is. You can only solve for y if you know what x is and if you know what this value is. I hope that makes sense. You can only solve if you have one unknown in the sentence, in the algebraic sentence. Okay, so right now we're going to solve for the smaller number. Once we know what the smaller number is, we can then find the larger number by adding 1. Because remember, they're consecutive integers, so it's one after the other. So if I solve for the smaller number, I know that the larger number is the smaller number plus 1. Let's try. Let's create our equation here. So the sum of two consecutive integers is 53. Sum means plus. So adding the integers together is equal to 53. So the smaller integer is x, and the larger integer is x plus 1 more. Okay, and now I'm just going to take that x plus 1 out of the brackets. Okay, and then collecting and simplifying like terms on my left side. And then isolating for x. Okay, so my smaller number is 26. My larger number is x plus 1, which is equal to 26 plus 1, which is equal to 27. This is my larger number. Okay, let's look at the next example. Mr. Smith operates a variety store with his two sons, Jerry and Kyle. Jerry makes twice as much as Kyle, who only works part-time. Mr. Smith makes $200 per week, more than Jerry. The total weekly payroll is $1,450. How much does each family member earn per week? Okay, so let's break down what we've learned in the information provided. So Jerry makes twice as much as Kyle. Okay, so Jerry is 2 Kyles. Mr. Smith makes $200 more than Jerry. Okay, so Mr. Smith is equal to Jerry plus $200 more. And then their total is $1,450. So the total is, we know the total. The total is $1,450. Okay, so between Jerry and Kyle and Mr. Smith, they make $1,450 in the week. Okay. So just as I was saying in the previous question, I only want one variable. I don't want a variable for Jerry, Kyle, and Mr. Smith, like different variables. I just want one. Because how am I supposed to solve for J, K, and S if I don't have any other information to work with? Okay, I want one unknown variable in my equation. Okay, just like over here, once I solve for my unknown variable, I can apply it to find the other unknown information in the question. So I'm going to do the same over here. So in my let statement, I'm going to let K represent how much Kyle makes per week. Okay, because all my information is actually relative to Kyle. That's why I'm choosing to solve for Kyle instead of Jerry or Mr. Smith. Look at the information. Jerry, the information is pertaining to Kyle. Jerry is 2 Kyles. Mr. Smith is 2 Jerrys, but we know that Jerry is 2 Kyles. So really, Jerry, we can replace Jerry with 2 Kyle. So Mr. Smith is actually 2K plus 200. Okay, and then over here, the total would be Kyle plus Jerry, which is 2 Kyles, plus Mr. Smith, that's 2 Kyles plus 200. Okay, so I'm going to actually just write that down. So Kyle plus Jerry plus Mr. Smith equals to 1,450. Okay, and I'm going to expand out of the brackets. Okay, and then I'm going to collect like terms on my left side, and then isolate my variable. On the left side. Okay, one thing to notice is that my equal signs are pretty lined up. Each step, the equal sign should be underneath the previous equal sign, okay? I know that's hard to represent in virtual land, so I'm not specifically looking for that with you, but in the future, when you are in class and writing this down to present to your teacher will appreciate neatness. In fact, your teacher may dock marks if it's not neat. So just something to keep in mind, something to practice right now is lining up your equal signs on each step so that they're one on top of the other. Okay, so now that I found Kyle makes $250 a week. Okay, so Kyle, which is equal to variable K, and K is equal to 250. Okay, Jerry is 2 Kyles, so 2 times 250, which is $500. And then Mr. Smith is 2 Kyles plus 200. So 2 Kyles plus 200. So 500 plus 200, 700. Okay, and the therefore statement, Kyle earns 250. Jerry earns $500. And Mr. Smith earns $700 per week. Okay, and make sure that you're including our units in your therefore statement. You don't need to include it in the process and the steps. I just want the unit in the therefore statement. Okay, last question. Kristen works at a ballpark selling peanuts. She's paid $6 per hour plus a 50-cent commission for every bag of peanuts she sells. just so that you know, when I'm going to include the 50 cents in my equation, I'm not going to write 50. I'm going to write 0.5. You can write 0.50, but that 0 doesn't really matter. It doesn't make a difference. So 0.5. I'm writing my cents in dollars form. That's something to remember when you are calculating money. Make sure that it's all in the same units. Okay, so cents and dollars is not the same units. So I'm converting all my cents to dollars. If you don't, you're going to get the wrong answer. Okay, so in question A, find Kristen's earnings if she sells 42 bags of peanuts during a 4-hour shift. So let's let E represent Kristen's earnings. And again, you can use another variable, whatever you want. Okay, so I'm going to get my sentence from I'm going to create my algebraic sentence from the words in the question. Okay, so her earnings is equal to her commission plus her wage. Okay, so her commission is, or actually we'll start with the wage. She's paid $6 an hour. And in question A, it says she works 4 hours. Okay, so 6 times 4. 6 hours, 4 hours times $6 an hour. Now her commission is 50 cents for every bag. And she sold 42 bags. So 50 cents a bag times 42 bags. Okay. So that's, so 6 times 4, that's 24. And then 0.5 times 42 is 21. And then 24 plus 21 is 45. Therefore, Kristen earns $45 if she sells 42 bags of peanuts in 4 hours. B, how many bags of peanuts must she sell to earn $100 in 7 hours? Let B represent number of bags of peanuts. Okay, so the question says that she must earn $100. Okay, so equals to $100. Now remember, how does she get her earnings? She gets commission, and then she gets her wage, and that represents her earnings. So it's 50 cents a bag of peanuts, and we don't know how many bags. The question is asking how many bags, so that's our B. And then in 7 hours, she gets paid $6 per hour. Okay, so that's a 6. That's not a B. So 7 times 6, that's 42, plus 0.5B is equal to 100. And I'm going to isolate for B. Okay, so therefore, Kristen must sell 116 bags of peanuts to earn $100 in 7 hours. There's a few questions here from 4.5 for you to try as well. If you have any questions, you can always private message me on Brightspace or email me.